Good morning here in Latin America, in Peru. I'm glad to be your host today in this International Industrial Ecology Day related to urban stocks, perspectives from the Global South. My name is Ramzy Kahhat. I'm a professor here at PUCP, the research group named PELCAN. We work on topics related to industrial ecology, and these topics include the study of urban stocks. For me and for Claudia and Matias, it's a great pleasure to have a 1 hour presentation on this topic in this Industrial Ecology Day for 2022. The schedule for today includes a presentation from Matias Gutierrez titled Assessing the Limits to the Growth of Urban Stocks in Areas with Horizontal Growth Constraints. Then we will have Claudia Cucchi with a talk titled The Urban Stocks in an Andean City and its Comparison with Coastal Areas of Peru. And after these two presentations, we'll proceed with a question and answer session. The first talk, as I mentioned, will be led by Matias Gutierrez. Matias Gutierrez is a civil engineer and currently a researcher at PELCAN. He has done work on life cycle assessment and material flow analysis, and particularly urban stocks, a topic that he will present today. Matias, good morning.
Yes, hi everyone.
Please proceed with your presentation.
Okay.
Perfect. Please go ahead, Matias. Thank you and welcome.
Great. So, hello everyone. I'm going to be presenting a research article that I wrote with Mr. Kahhat this year, and it's titled Assessing the Limits to the Growth of Urban Stocks in Areas with Horizontal Growth Constraints. Right here you have the link if you want to check the article, and let's begin. So first of all, a very small introduction on why the study of urban stocks is important. So urban areas accumulate an important amount of construction materials, right? These materials need, let's say, some raw materials for their production, so that has an environmental impact. Then when buildings are demolished, they need to be disposed of, so they can have an impact as well. And also, let's think that these construction materials in buildings can be considered a repository of future resources that can diminish the impacts on both natural raw materials, which was the first thing I mentioned, and then they can also help to diminish the requirements of landfills, which is related to the second part I mentioned, end of life stage. Now, when we were looking for topics to cover on our case studies, we realized that while several authors have studied the possible growth of urban stocks, no studies had actually addressed the growth limitations of the urban stock growth. For example, some authors have determined that while industrialized regions have achieved a stable growth, development regions still grow at constantly increasing rates. By the way, this study also determined that there were barely any areas that had achieved a constant stock. So when I say stable growth, of course, I mean that it's still growing, only at a stable rate. Now, considering this knowledge vacuum, our objective was to not only quantify the current urban stocks in 2 districts of Lima, which is what the the area normally does, but to expand on this by exploring the impacts of zoning, urban and building parameters on the maximum possible growth of urban stocks, particularly in areas with horizontal growth constraints. Why areas with horizontal growth constraints? Well, many studies, when they try to analyze the growth of urban stocks, they correlate with some socioeconomic variables, very commonly population. But of course, this correlation assumes that the city can just grow along with population and has no limits, right? So we picked specifically horizontal growth constrained areas to show how when there is a limit to this outward growth and you can only grow vertically, there can be restrictions on the growth of stocks. The districts we chose to study were San Isidro and Lince, which are two neighboring districts in Lima, Peru, and they both have strong geopolitical boundaries, which explains why they cannot grow horizontally. How did we study these stocks? Okay, so we set up one current scenario and one maximum scenario. For the current scenario, we basically did a bottom-up approach, which means we took municipal GIS databases. We studied some zoning distributions and urban and building parameters. These zoning distributions and urban and building parameters were used when municipal GIS information was not sound enough to have all of the required information for classification, which basically means building use and gross floor area inside of every lot of the district. We also did some verification where we used validation, where we used Google Street View, satellite imagery, and also very extensive field work. Now, for the maximum scenarios, which means that we had to quantify how much the GFA on lots could possibly be inside the district, we also used municipal GIS databases, but also only for determining the possible size of lots. And then we used the urban and building parameters and national building norms, where we basically took open space regulations and we only used the minimum values, and then maximum stories for each lot within each zoning type, right? So if the parameter said that a lot could have 10 stories, we exploited it until those 10 stories were used. Now, we also used some expert opinion just to be sure that some of these regulations were actually possible, because some regulations said, for example, that in commercial lots, you can have 0% open space regulations. And we thought that that was not always possible. So we used some expert opinion to cover these issues. Now, going forward to the material intensities, we link to determine urban stocks, we link gross floor area to material intensity. And these material intensities were basically determined by related literature. We analyzed some building documents, related those to design codes and material supply information, and determined some values that helped us relate GFA to material stocks. All of these material intensities, by the way, you can find on the supporting information from the article. Now, linking current building stocks and maximum building stocks with material intensity, we could establish the current scenario and the maximum material stock scenario. Now, a little comment about our bounding scenarios. Of course, we are trying to determine the maximum building stocks, but there are several ways to try to determine this, right? For the first one, we assumed that we could only use strictly the urban and building parameters. So for example, for commercial areas, we assumed that it was possible to have 0% open space. And then for the actual use of buildings, we assumed that if a building is within a commercial lot, it will be exclusively used for commercial purposes. So for example, offices, right? For scenario 1B, we assumed that all commercially zoned lots would not be used for commercial purposes, but actually for residential purposes, because there is a use compatibility that municipalities allow. We also use strict use of the parameters from the norm. And this scenario, just a heads up, will be useful for population determination, but not so much for determining material stocks. And then bounding scenario 2, which is the most important one, I think, is where we used the current typical open spaces for the commercial sector. So we think it's a bit more realistic, but we also assume that all commercial lots will be used for commercial purposes. Okay, so let's go on to some results. Here we have the distribution on the left of current urban stocks in both San Isidro and Lince. San Isidro is the one on that has the shade of blue, and then Lince is the smaller one, which is represented by the green on the smaller map. Then to the right, we have something that is defined as remaining urban stock growth, which basically means the maximum scenario, which would be scenario 2 for this map, minus what is currently there. So minus the information we have on the left. Before I give some details on the maximum scenarios, I would like to state that to the left, we can already have some conclusions on how these districts are distributed. For example, Lince, we can see it has a very uniform stock presence, right? We can see that most of its stock is located in the range of 1 to 5 metric tons per square meter of surface area. While San Isidro, to its eastern and western boundaries, has a presence of basically single family housing, and it has these very market areas where it has between 0.5 and 2 or 0.5 and 1 metric tons per square meter. But then it also has these specific areas in basically business and financial zones where the material stock just skyrockets from 10 to 55 tons per square meter. Then to the right, we can see basically that San Isidro has many areas where saturation has already been achieved. A gray area would mean basically that. And then it also has some areas where we're unlikely to see some growth. This would be the yellow and light orangish shades, because that would mean that basically the stock can grow 1 to 2 floors, and we consider it unlikely that someone will demolish, let's say, a 10-story building just to build an 11-story building, right? So it has many areas where its stock has already seen this expansion and is near the limits. Lince, on the other hand, basically 60% of the district has a staggering growth potential. We can see that basically this whole T area, sideways T, can grow on the 55 ton per square meter range. Okay, but what about not only spatially determining these growth capacities, but just on the district level? As I've said, Lince has a higher growth capacity than San Isidro, and this is true no matter what scenario we consider. So San Isidro's current stock is 11.6 megaton, which is much larger than Lince's 4.7, but it's much larger because it's also a larger district, and also it has already experienced much of its densification process. But San Isidro can still grow 2.2 times, as we can see in the graph, which are the blue bars. And this would mean an increase of 19 megatons. And then Lince can grow 3.8 times, which would mean a very drastic increase of 13 megatons. If we divide these growth potentials by zonings, we can see that there is difference between the residential and the commercial sector. Now we define this variable we call saturation, which means current stocks over maximum stocks, and we show the results for scenario 2, which again we consider to be the most plausible one. As we can see, San Isidro's residential stock, for example, has 58% of saturation, and we consider that this means that it's approaching maturity, while Lince still is on 43%, and while it's growing, it still has much more room to grow. Surprisingly, both districts have very underdeveloped commercial zones, and Lince is barely under the 1/5 mark of its limits. Now, stock distribution by heights can also help us determine a district's aspirations as well as possible hotspots. What do we mean by aspirations? Okay, let's see the case of Lince, for example, which are the darker shade numbers on the graph. Okay, first of all, let me explain what the height ranges mean. Sorry. On the 0 to 3-story range, we have this typology called confined masonry single-family houses. Then on the 4 to 5-story range, we say that low to mid-rise buildings basically mean the legal limit of the confined masonry system, which was one of our defined typologies. On the 6 to 12 and 13 to 30, we have the second residential typology, which is called reinforced concrete. And this basically means residential and office buildings. And although 30+ stories is not defined as skylines in some cities, in Lima, this can be considered as a skyscraper. So we consider this range to represent skyscrapers. Okay, so why do we say that we can determine a district's aspirations from this? Let's see San Isidro Lince's current scenario. We can see that 50% of its current material stock share is present in confined masonry single-family houses, right? And we have barely 20% low to mid-rise buildings, which still means small apartment buildings. And then smaller presences of mid to high and high-rise buildings, basically no presence of skyscrapers. But on its scenario 2, so on its limit scenario, we can see that Lince has no regards for its single-family housing. However, we can see that the high-rise buildings skyrocket, meaning that Lince's current norm basically has what it wants to do is to incentivize construction and not to reserve areas for different kinds of dwellings, let's say. And then San Isidro also shows some evolution, but it's much more distributed, right? So San Isidro's current scenario shows a very well distributed from 18 to 20% to 28% on basically all ranges. And in its future scenario, we can see that, for example, houses and low-rise buildings, while they diminish, they still maintain a part of the stock, which means that San Isidro still wants to maintain some of its residential status. Skyscrapers skyrocket in San Isidro because it allows very tall financial and business buildings. Now let's talk about scenario 1B very shortly. Scenario 1B, as I said previously, considers that all commercial buildings can be used for residential purposes. So this is basically allowing us to determine the maximum amount of people that could be housed within a district. Now we know that population growth is commonly the cause of the residential built environment expansion and not the effect of it. But this can be helpful when planning capacities for service infrastructure because we know how much it could expand, right? So for example, San Isidro on scenario 1B could expand from 60,000 currently to 165,000 people. And then Lince, it has two options within scenario 1B. Currently, Lince has 49 meters per capita of living space, which is much lower than San Isidro's. But Lince shows a trend of upward socioeconomic status, and it could be approaching San Isidro's values. So if it stays the same with 49 square meters per capita, we could have a staggering 250,000 people. And that doesn't sound very realistic, but if it grows, if this value grows to resemble more San Isidro's values, we can see that it could grow still from 54,000 people to 91,000 people. Now, to close out the results, San Isidro's current stock per capita is higher than most other analyzed cities in other urban stock studies, while Lince's is basically on the low end currently. And here we can see that for their maximum limits, let's say, they could grow to be even greater than some other cities that have been analyzed. For example, we have Wakayama. And Wakayama is also located in a seismic area in Japan. So this means that their urban stocks are very high. But San Isidro has higher urban stocks than Wakayama currently. And then in its maximum scenario, its stock per capita value just skyrockets to 341. And Lince, depending on this possible change of square meters per capita that we have discussed, it can be between Vienna if it's on the low end, but it skyrockets to an unimaginable 536 if it goes, if the square meter per capita remains the same as currently. Now, to finish up, what are our key takeaways? So you might be thinking, okay, so we can study these hypothetical limit scenarios for urban stocks. So what? Okay, generally, we think that zoning, we have determined that zoning is a limiting factor for the upward growth of horizontally constrained areas, and it should be considered when analyzing an area's growth and resource potential. So on its resource potential, I think this is clear, right? If we know how much the district can grow, we can plan how much we can urban mine or extract from this built environment. But then what about some other useful facts about our approach? Okay, height and geographic distributions can help determine hotspots. For example, if we have the geographic distribution of the possible growth, it can help authorities focus on environmental actions on high impact areas. Me and Mr. Kahhat had a study recently, a report linking emissions from materials with the possible growth of districts. And we could map these emissions, possible emissions rather, to areas, and this information could help authorities, let's say, encourage specific areas or target specific areas for the use of environmentally optimized materials, right? And then on second place, what authorities are allowing to be built, so their limit scenarios, can have long-lasting repercussions for urban services. The literature refers this to as path dependencies or lock-ins, and what is being allowed to be built can have effects on the installed capacity we require from solid waste management, energy supply, traffic management. For example, traffic is linked to if a zone is commercial or residential and how its inhabitants, let's say, move from residential to commercial places. And then we can also see effects on the energy supply. For example, if a district grows exponentially on residential areas, then its energetic profile throughout the day is different than if a district has more educational or office areas. So of course, the infrastructure needs to prepare for this. So that's it, basically. If you have any questions, you can ask now, or you can contact us via email. And thanks for the attention.
Thank you very much, Matias. Great presentation. As I mentioned before, the questions and answer session will be after Claudia's presentation. So please prepare your questions. You can start preparing your questions using the chat box, or when it comes to the time of this Q&A part, we can ask the questions using the microphone. So now it's time for Claudia Cucchi. Claudia will present an ongoing work related to urban stocks, and this time a comparison between what happens in the Andean area of Peru with other studies that we have published on the coastal area. Claudia, welcome to this Industrial Ecology Day, and thank you very much for making some time to present your work. You may start.
Okay, thank you for the introduction and thanks for having me. today. Can you see my screen?
Yes, everything is perfect, Claudia.
Okay. My talk today is about a urban stock in an Indian city and its comparison with coastal areas of Peru. The importance of urban areas for society are undeniable and replicate around the global following different patterns and connect with cultural and socioeconomic aspects and necessities. So, some answer to questions related to the evolution of cities and the influence of this aspect can be extracted when we analyze the urban stocks. Thus, the comparison between urban stocks in different areas of the world can give us more information about their sociocultural characteristics. Although, as we know, the study of urban stocks and their socioeconomic drivers is growing, but there are still many gaps that need to be filled, especially when we're referring to the analyzed locations and particularly the great diversity in the global south. As an initial step to understand the differences in urban stocks, this study explored the stocks of urban construction material in building sector of 5 urban areas of Peru, having the Abancay city as the center of the analysis and compared with others in the coast zone. The 5 urban areas analyzed, as shown in the table, have different geographical locations, growth limits, and socioeconomic levels. So, as I mentioned, 4 urban areas to be analyzed in this study are located in the coast. 2 of them are cities, which are Chiclayo, one of the most important macro-regional metropolises in the country, and the other is Tacna, a city with more than 250,000 inhabitants. On the other 2 areas, we have San Isidro and Lince, which are districts contained in the national metropolis of Lima and host around 60,000 inhabitants each one. Both of these districts have horizontal restrictions, as Matias mentioned before. And in this research, Abancay hosts more than 70,000 inhabitants and is the central case study and also represents a main city located within the mountainous region of the Andean space. Okay, moreover, 3 residential building types were identified in the different cities. We are talking about adobe houses, brick masonry houses, and the last one is reinforced concrete apartment buildings. Well, the material stock was quantified through the traditional bottom-up methodology. To do this, the basic equivalent of the stock of materials is equal to the gross floor area by the intensity of the materials. So as shown in the figure, we combine material stock analysis with GIS technology for the quantification of building stocks and its geospatial location in the selected urban areas. So the first step was to determine the categories by the use of the buildings and characterization of the most common building typologies used in every area. And for this purpose, a database is created in a GIS model by digitizing and managing various municipal or census maps. Moreover, material composition for every building type is analyzed to later calculate the material intensity. And after that, the next step integrate the GIS model with the material intensity. So we can have the spatial distribution, which is shown by means of main construction material over the ground area. And finally, the temporal evolution of the material stock is obtained from the projection of known information combined with the past and the present census statistics. Well, the main results showed that the total material stock for all building types in Abancay, was quantified at 6.5 million tons for the year 2012, or a per capita value of 110 tons per capita. But if only the residential sector is considered, the values could be reduced to 84 tons per capita. The main material types in Abancay's building stock is mineral materials, as we can see in figure B, of which adobe with 2.2 million tons and concrete with 1.8 million tons are the most predominant materials. Also, in figure, we can see in figure A that present the material stock in different types of buildings. Adobe is present in the 4 different types and is the main material in residential building, followed by the stone and mat and concrete. Well, stone and mat are material used as a foundation for the adobe dwellings. Furthermore, we can see that concrete is the principal material in commercial, institutional, and industrial buildings, which can be explained by its better ability to maintain proper functions in the face of seismic crisis conditions. Now, we have the geospatial distribution of concrete and adobe materials. As seen in the picture, a more uniform distribution can be found in the case of adobe, which find a slight concentration in the urban center and is dispersed to the rural outskirts of the city. This means that there is not necessarily a marked difference between the more economically consolidated sector and the outskirts of the city in terms of the use of adobe. On contrary, the concrete map shows that concrete has a special distribution with a greater presence in the center of the city and the eastern zone, as we can see. Of the studies, first of all, the study used material and stock analysis to characterize and quantify the building stock and compare urban stocks in the Andean city of Peru with others in the coast. To sum up historical development of the stock and the different buildings, types, and materials, like substitution of adobe by other materials or the construction type buildings were developed. Also, spatial distribution of stocks depends on economic development of the urban areas, such as urban densification with more parking zone, or the uniform distribution of adobe houses in the case of Abancay. Finally, similarities and differences between the urban agglomerations and their development, such as significant differences in the per capita stock of residential building, were developed for the studied areas in Peru. Okay, that's all. Thank you very much for your attention. That's okay.
Thank you very much, Claudia. Great presentation. So now it's time for the Q&A session, and everyone is invited to ask their question. You can use the chat box if you want, or directly using the microphone.
Now, can you hear me?
Yes, Gustavo. Good morning. Good afternoon in your case.
Yeah. Hey. Thank you for the presentation. I was curious about a presentation that Claudia did, and she was talking about social indicators, and she found some correlations between poverty and the most predominant material in construction. And I was wondering that if you have reflected on the economic development of the country, and if there's an increase in the economic condition of the population in Abancay, especially Abancay, do you think that it will change the patterns of material selection, or it would only accelerate the change of materials? Because you were saying that adobe and masonry are replaced by reinforced concrete. And I was wondering, if the economy goes better, is this tendency going to be different, or is just going to accelerate it? Basically, by this I mean adobe going directly to reinforced concrete, or adobe going to, for instance, masonry. Do you think it depends on these indicators, or, well, I don't know.
This is a really important question. I don't know if Claudia, you want to answer the question, or?
Yes, the economic situation of the region, specifically in Abancay, which is the capital of Apurímac, has changed currently. For example, in Abancay, there is a minimum canon that is originated by Las Bambas, that affects the growth of the stock material accumulated in the building stock. So this socioeconomic change in its inhabitants or in its population has driven the transformation of the construction system and the use of different materials like cement, steel, and other, no? This is the reason how or why is this transformation of these rural or traditional materials with adobe walls to the new construction system with the concrete reinforced buildings. That's okay? Or
No, great, Claudia. And it's really a really important question, Gustavo. We don't pretend to actually answer that question. However, what we're trying to say in this paper that will be submitted soon is to see what is happening, okay, and comparing what has happened with regards to materials in the different cities that we analyze. So San Isidro phased out adobe long time ago. Surprisingly, in Lince, we found that in 1980s, 1985, there was still a share of houses containing adobe. And then if we go to Tacna and Chiclayo, the share is higher, but decreasing. A really interesting thing that we find in Abancay is that the share is much more important. So one question is if this relates to, for example, what actually happened in these districts or urban agglomerations long time ago. Another thing is if the cultural imperative is something that is in a way influencing the share of adobe houses, or the other thing to say if people are seeing new other materials, more like not new materials, but less traditional materials like concrete or masonry as the new trend. So these are a lot of questions that we have in mind. We actually will love to have an answer based on the information that we have, but we need to accept that this is probably not possible. We can get close to, but we need more, let's say, research on different areas to actually answer that question.
Thank you. Thank you.
Thank you so much, Gustavo.
Thank you very much, and I think we are close to the end. So if there are no more questions, I would like to again thanks to everyone to being part of this Industrial Ecology Day and the one related to LATAM. Thank you very much, and hope you enjoy the rest of the day. Take care.